Okay, let's get started then. Good morning, everyone, or good evening, or good afternoon, depending on where you are. Welcome to Acri's monthly meeting. Today, we're going to go through a couple of things. So we'll start with an announcement. So I'll start with about Acri's blog. So Acri's blog is hosted on medium.com. We just had a recent post published by Kate about Acri's extensibility model. You're welcome to view the blog and participate and leave your comments. We'll be posting more to that as we go through the rest of the year and the releases. So next, we're going to have we have a couple of things on our agenda today. So Akri has presence in KubeCon Europe. Kate is going to go through how that went. We're going to have a triage, and then Edric is going to speak to us about donating Akri to a foundation, and Chan is going to walk us through a discussion about MQTT. So starting with KubeCon, Kate, how was that? I want to brief us in on that.
Sure, thanks, Roa. Hi, everyone. I'm Kate, one of the maintainers for Akri, and it was exciting. But a couple months ago, we went to KubeCon Europe, and we presented a main session that was basically an introduction to Akri, and then Edric also presented a lightning talk on the breakout KubeCon Edge Day. And just to share some of those stats of participation, we had on the main session side, we had 117 people show up live. And then throughout the rest of KubeCon time, by the end of it, about a week after, we had 230 people view the session. And then now it is posted online, and we can link into the meeting notes after this, the link to that, but it's on CNCF's YouTube page. And I think currently we have like a little over 100 views. So the views keep trickling in, and that's a good video for people who aren't familiar with Akri. It's about 22 minutes, I think, and it runs through everything from the motivation behind Akri to why it's named the way it is, to some example scenarios, and a little bit about its extensibility model, which Roa mentioned earlier with the blog that recently came out, which further details that. And then some other things, other stats around this talk. We had just about like the growth of Akri due to KubeCon EU. We had about 15 people join our Slack, which is like a 15% growth right around the time of the conference. And then that number has consistently been trickling up as well. And then we had 374 people view our GitHub page that week. So definitely directly from searching it online. And that's just from GitHub's insights that you can see with your repositories. So that was an exciting number to see, people just openly searching for Akri due to the presentation. And then we also had 110 unique clones of Akri that week. So people are trying to play around in the code and seeing what it is. So those are all exciting stats. And then also after the presentation, we had 15 minutes for Q&A. And those questions kind of showed what the community was thinking about Akri. They were very targeted questions, which showed that they were engaged in the presentation. And then just to share some of the stuff, some of the questions that they asked, via the questions, we were able to affirm that Akri runs both on ARM v7 and v8 and x64 nodes. That was a question about what platforms do we support. And we were able to confirm that Akri can be extended to discover new devices in any language with its new extensibility model. So while its core components are Rust, which one person commented, that's really cool. The way that Akri can be extended to more devices is language agnostic. Other questions that people had was about whether Akri had been stress tested. So what's our scalability model? How many devices have we tested Akri on, and how many nodes? For example, one person asked, like, have you explicitly tested this on 50 nodes? And the answers to that is no. And so that was a key area of growth, and a place where if someone in the community is interested, try try stress testing Akri. Let us know how it goes. There's definitely work that can be done there. Also, listeners wanted to know about how Akri handles device authentication. And there has been some discussion on that. With OPC UA, we handle shared root certificates, but we haven't looked into other authentication scenarios like IP camera authentication, and there's areas of growth there too. So if people have ideas that they want to share around that, there's further discussion that can happen there. And then as to other questions, people asked whether we support other IoT protocols such as MQTT, which Shan will discuss a little later on what our thoughts are currently with that, and LoRaWAN. Those were two that people specifically pointed out. And Akri is definitely a goal of its growth is to support more of these IoT protocols. And with the new extensibility model, hopefully that is becoming an easier process. Finally, people were interested in understanding where Akri is going to go, what's next for Akri. And one explicit question someone asked is, did you consider submitting this project as a CNCF sandbox project? And that is something that is on our agenda today, is talking about what foundation Akri will hopefully land in. So those are some of the key takeaways. Obviously areas of growth, and then also areas that we are excited to say we have grown in. So it was a great opportunity to speak at KubeCon EU, and we submitted 2 proposals for KubeCon North America, and we'll see if we get accepted to those, and hopefully have another opportunity to share Akri broadly.
Thanks, Kate. Thanks for sharing that. Looks like KubeCon was a great place for Akri to get a lot of interactions. So next on our agenda, we have issue triage. Brian, I can stop sharing, and if you want to share your screen instead.
Thank you. I'll try and share here. Let's see here. Oh no. It's like I can't share just yet.
Okay.
That's okay. If you want, so if you can share your screen and just open up issue 334. That's the first one I was going to talk about. Really, I'm just talking about good first issues, first items for people to try as they're being introduced to Akri.
You got it, Brian. Okay.
So it's that first one, execute workloads based on labels.
Oops. Okay, hold on. I clicked on the wrong one.
There we go. This issue reflects, I know when we first started creating GitHub Actions, we wanted to create some, I don't know, we'll call it customizable, I don't know, reactions to a PR. So they're, generally speaking, our PRs execute a lot of workloads, but sometimes maybe we didn't want to do certain things. So we introduced a set of text strings that you could put into your PR title that would, for example, we don't actually let people build the intermediate builds because they take so long unless you put something into the PR title, basically saying enable, I forget, intermediate builds or something. But this is kind of, I don't know, it feels very hacky, and labels sound like a great thing to get around that problem, that we could add a label and then query the PR for the label. So this would be one thing to do. Essentially, it would be to go into the workflow files, and everywhere you see kind of some text looking for specific strings, you would start looking for labels. So that's I don't know, maybe that's a little more advanced for a first item, but it's very much, if you know GitHub actions well, then this is probably not a complicated first item for you to work on. So the next one, I think, is a simpler one. If you go back and it's include Akri. So it's number 268. Here it's about halfway down your screen, include Akri configuration instances in that one. So this is really, I think, just a matter of adding a little bit of text into our CRD installation that tells Kubernetes to include our CRDs in the get all. I think that Daz did a good job of hunting down pretty much all the details here. So I think this would be a pretty good first item too. Pretty simple, self-contained sort of change. Let's see the next one. So you can actually, if you click on the labels button right next to the search field, oh yeah, you can do that too. And then click on good first issue. We can just see the first issues in general, and then there'll be a quicker version of this. So the next one I wanted to highlight was container best practices is to use entry point rather than CMD. I think this would be a good one to get in. I think it's not super complicated to implement. I think that there may be some test failures that we see because of it. So there may be some associated changes, but really, this is just a matter of finding all of our Docker files that the last line is CMD and updating it to use entry point instead. Like I said, there'll be a couple more changes that you have to make, but really nothing super big. So I think this would be a good, it's just creating the containers and then making sure all of the workflow checks actually pass, all of our CI passes. So I don't think that's super complex either. The last one I thought would be an interesting one is, I think it's down at the bottom of the list or towards the bottom of the list. It's the third one up, feature request support of customized install. Third one from the bottom, sorry. Right now we've got Helm as an install thing, and this came in as a feature request to add customize. I don't know anything about customize, but it sounds like an interesting first step to do. It doesn't require probably an in-depth knowledge of the inner workings of Akri so much as, you're just sort of translating Helm into whatever this new install customized format is. I suspect that there are other Kubernetes installations out there too that we might think about supporting down the line. So this might be a first step towards having multiple supports or multiple ways of installing Akri. So those are the four that I sort of highlighted. I think any of those would be good ones for someone to come in and try out, and be useful to us too as a project. That's all I got.
Thanks, Brian. That was great. So I think those are good ones. Hopefully anyone here today can pick one of those and help out. So let's go back to our agenda. So next we have Edric talking about donating Akri to our foundation. Edric, would you want to present?
Sure. Let's see if I can get the host rights here. I think there it is. Let me pull this up. All right, so everybody can see my screen. It should be on the CNCF GitHub page with the Cloud Native Sandbox pulled up. Wonderful. So as we move along with Akri, it's kind of evident that the success of the project is correlated with the number of contributors as well as the number of devices that are supported. As more devices are supported, the bigger the ecosystem of Akri kind of grows. So we've kind of come to this point where it makes sense to donate Akri to a foundation, whether that is like the Analytics Foundation or any of the subsidiary foundations like LF Edge, CNCF, and there's a whole bunch of other ones. So kind of walking through that, we looked at all the different foundations to see where Akri might belong, and kind of going through that. The most obvious one to us and the most fitting seemed like the CNCF, or the Cloud Native Compute Foundation. Akri from the beginning was built on top of Kubernetes native technologies. It was intended to extend Kubernetes to enable devices in a cluster. So the CNCF seemed like a fitting home for it. So kind of looking down that route and seeing what how Akri can be adopted in the CNCF. The first step is something called the sandboxing, which is the lowest commitment and lowest tier of CNCF projects, which it states here really it's just to get the process going. When a project is inducted into a sandbox project, it's a rather low commitment. It's a rather low commitment process. It's really there so that the CNCF can help out with expanding the ecosystem, as well as giving it a little bit more visibility, so that during events like KubeCon, as well as other keynotes and events that they have, that they can properly bring up the project and kind of guide it and bring on more contributors and grow the ecosystem that way. So kind of opening up the stage, what's everybody's thoughts on this? Does anybody have any sort of opinions on the foundation that we're going to go with, as well as just overall thoughts?
I think it might be interesting to show some examples of some CNCF sandbox projects. Is there a page where all of them are?
Yep, I can see if we can find what's the best way to do this. Let me stop sharing for a second. The CNCF landscape should be the best place to find it. It'll take a little bit while to load because there's a lot of them. Go to card mode. Let me share my screen here. So going down the list, these are the graduated projects. These are the most mature incubations. And then we can scroll all the way down. There are a lot of sandbox projects because sandbox is like the lowest level of commitment. Basically anything that is sort of related to Kubernetes can be inducted into or anything related to cloud native computing can be inducted as a sandbox project. So there are a lot. It'll take a while to load. Let me see here, actually. If I go to process, there are some past projects. If I go into proposals, if I go to sandbox, we see here's a whole bunch of different other projects that previously have been sandbox projects that have not, a lot of them have graduated. Something I can also pull up here is looking at the process. This kind of highlights the stages of a CNCF project. So what we're aiming here is the sandbox, which, as I say, is the lowest barrier. And then this basically is sort of like, in some sense, like kindergarten, and it kind of prepares you to be incubation. Theoretically, you can jump directly into incubation, but that is rather difficult without the help, without going through a sandbox project first.
Adrian, do you mind if I jump in and add a comment here?
Yeah, absolutely.
Yeah, just a quick thought. Maybe it's might be interesting not just to put it out in CNCF. It depends on what problem you guys want to solve. So at the end of the day, it's if it's Kubernetes, then of course it's CNCF. But if you're, let's say, planning to showcase a lot of things in edge computing paradigm or something, probably it might be interesting to talk with the working group which focuses on the IoT and the edge part in CNCF. Maybe I'm not too sure about it, but maybe there might be some similar projects out there that where you can, for example, come up with a Venn diagram or whatever that shows you the overlaps and differences between those kind of sandbox projects or whatever other projects are out there in the edge working group. I'm aware of one which is, I think, called OpenYurt. So I think it's pronounced Yurt, if I'm not wrong, YURT.
Mhm.
And I think it's also part of CNCF, but it probably is also similar to, for example, working on the edge computing part of let's say about bringing orchestration on the edge and everything. So might be interesting to maybe dabble somewhere in those bushes too.
Mhm. That's a very good suggestion. Something that's part of the sandbox application is doing sort of the due diligence and looking at what other projects exist out there that are similar and how they relate to the project that's being applied or being submitted. Um, I'll, we'll take a look at OpenYurt as well as sort of like, as you mentioned, the working groups around edge computing and to see what other projects are out there. I think insofar as we know, I think within the CNCF, there aren't too many that are overlap, although there are projects out there that kind of do similar stuff. Like from ARM, they have the Smarter project. But yeah, I'll definitely take a look in at OpenYurt to see how much overlap there is too.
Yeah, and I think following that up, we have spoken at the Edge Working Group before. So I think maybe going back to them would make sense as we are moving forward with this next step, because that was something that they asked us when we discussed there a few months back. And just kind of circling back in does make sense. And also, thanks for pointing out OpenYurt. I'm definitely gonna look at it a little now too. Makes a lot of sense.
Yep, those are very good suggestions. In terms of the timeline of this, the sandbox projects are considered once every 2 months. I think the next consideration round by the technical oversight committee is in June, so this month. So at some point, that might be a deadline that we're aiming for if we decide to go with the CNCF and sandbox project.
Shan, is OpenYurt more focused on heterogeneous nodes or the tiny devices around them? From a brief look, it kind of looks like KubeEdge, but it's literally just from pulling it up real quick.
Unfortunately, I haven't had any time to go through it, but I was made aware of it through one of the sub channels on the CNCF part. I mean, on Kubernetes, I think they have this working IoT group sub channel, where apparently someone posted something about OpenYurt, and I was just going through the docs and everything. I'm not sure. I haven't had any experience with it, but I'm just aware of that there is something out there, at least in the IoT / edge computing part in Kubernetes landscape. So
yeah, it almost looks like OpenYurt might be another platform to run Akri on from a brief look, or alongside with. I wonder if they would work together. But yeah, I will definitely look at it more.
Wonderful. So I'll pass it back to you, Roa.
Thanks, Yadrik. Looking forward to the updates on that in the next Akri meeting. It's exciting. So next on our agenda, we have MQTT. Chan, as Kate mentioned, that was one of the things that came up in Akri's KubeCon Q&A. So thanks for suggesting that on the agenda today. So back to you now. How do you want to get started on this?
Yeah. I'll just share my screen. I have a couple of slides prepared for it, so maybe it might be interesting, even in hindsight, to go through the videos and maybe get some better idea for someone who's not part of the meeting. So I'll just share my screen. There you go. I hope it's visible to you guys. Yeah. Okay. So yeah, just a quick heads up. So I've been working with MQTT for about 4 or 5 years now. I've had some good grips on it, and just to breeze through the whole protocol stuff, it's more or less a publish subscribe mechanism, a messaging protocol, which is a bit more lightweight compared to the big guys out there like Kafka or maybe RabbitMQ or something like that. So it's mostly well oriented towards, let's say, completely powered to low powered sensor network. So you can actually get MQTT compatibility with a lot of microcontrollers, as well as single board computers, as well as big industrial PCs. So it's quite well known. So it usually it's like, the idea is, it's rather than asking someone for something, you just proactively say that this is me, this is what I do and publish, and then you push it to the broker, and someone who's interested on the other side might just subscribe to that information accordingly through concept called topics. Topics are generally like strings which are separated by the slash characters over here. And the protocol itself is very flexible. So it doesn't care about what you name, how do you use your topics, how do you define your payloads. There's no strict definition for that. But it just defines how the messaging protocol works. So on the, let's say on the layer 4, layer 3 and everything, that's where the definition actually lies. So like I said, it's pretty agnostic towards all this kind of description information and the payload that, let's say, your MQTT clients publish to the broker or to some other parties. Since it's so flexible enough, so that means it's quite often that I've observed is, for example, a lot of IoT applications in general in the feed out there publish information in like JSON format. XML is quite rare. However, there can be a possibility because there are still some legacy systems out there that still use bulky XML as their payload. There are other standardized serialization protocols out there where you can, for example, compress your payloads, or maybe serialize them in a certain stricter manner so that you can run this protocol on like sensor nodes which are actually just running on battery power. So you can save a lot of effort in that aspect. And it's got nice nice features inside it. So there's like things like you can have a session between the client and the broker. That means once you made yourself available to the broker knows who you are in that aspect. So that's like a session management. And let's say if you're dying out, if the client itself has some form of problems and everything, it has this concept called last will and testament. So that means before I die, this is what I preach to the broker, saying that I'm probably not available for some certain amount of time, and then this is the last message that I've ever sent out. And it's quite popular. So there are lots of foundations and industries out there who actually use them and have let's say complete compliant brokers out there which people can use for many use cases, as well as prototyping and everything. So just a simple example, this could be an example where I used it previously in one of my works, where you can define a topic saying, okay, this is me, I'm from Acme, I have a company somewhere in Dallas, and this is what the information comes out. This is an example, a quite common example is inserting data directly or indirectly, so to say, into a time series database. So you can send out a nice string which has a lot of information. So the temperature and humidity, if that's a sensor that you're really concerned about or caring about, then you probably send this information in your payload, maybe a timestamp, so that you know that this was when the temperature readings were occurring, and then you can add some small metadata here and there. Correct. Like I said, so the protocol is quite nifty in that aspect. However, I was thinking about it in terms of implementing it in the Akri aspect. So chances are initially, I'm not sure how much flexibility I could imagine myself, for example, developing an MQTT part for Akri might be. So chances are someone has a very different set of topics that they need to subscribe to, some different form of protocol payload or something like that. So I was thinking maybe we can just go down the whole narrow aspect of it. So maybe we can find some specific open source specifications out there that actually use MQTT but don't change the protocol per se. But then, for example, leverage that protocol and maybe come up with some standardized format. So like I said, I think Sparkplug B from Eclipse Foundation is picking up pace eventually. So I've been part of their communities here and there, and I've been trying to get some more information out of them. And it seems like they have some form of understanding of how, let's say, definition of how they want to use MQTT to make things a bit more standardized. So that means if you have a machine that can talk, that can communicate information in this Sparkplug B specification, and a small sensor, maybe even a huge robot that can actually talk and convey this, the message to a broker, and then the clients themselves can be a bit more standardized. That means the data that comes in is pretty much understandable by a large aspect of a large facet of these kind of end user clients. So so they have a topic definition over here. So this is like a syntax which has like, okay, you define a namespace, a group ID, a message type, edge node ID, and device ID. So these are all, there's a online documentation which specifies what each of these sub levels are. And their payload is actually quite standardized in an interesting way, because they tend to use protocol buffers. So you can, if it's a big machine or a small sensor, if you can create your data in such a way and then send it out on MQTT by let's say encoding them in protocol buffers, which they have files for. That means that at the end of the day, whatever end user wants to use that data doesn't have to worry about what date time, for example, is in the payload, and what let's say whether if it's a string, if it's a long integer, or whatever, right? So it's a float or something like that. So they've actually put some effort to standardize the usage of this protocol. Correct. If you guys want, there's a website which actually has the complete specification on it. It's quite small, about 30-40 pages, and then it has some payload specifications for the protocol buffers that you guys see over here. It's already there on Sparkplug eclipse.org. So my thought pattern was, maybe we can go down a very like a narrowed approach towards integrating MQTT with Akri. That means we have a very strict form of let's say protocol specification, and then once, if this becomes successful enough, maybe you can take some lessons learned and then say, okay, maybe if we just give the end user changes in this environmental variable or this configuration file, chances of this application becoming much more generic might be interesting. So like I said, so since it's just a protocol and it doesn't tell the user, it lets the user use it as freely as he or she can. It might be complicated in terms of implementing this aspect, for example, with Akri. So maybe that's a good idea. Maybe we can start strict and then loosen up the ends once we realize, okay, this is something that we can actually make it much more customizable. So what it actually looks like in terms of Akri is, I went through the OPC UA example documentation that the repository already has, and I was just trying to, let's say, overlap the logic behind OPC UA and maybe MQTT over here. So first of all, it's pretty standard. You can write a monitoring configuration which goes to your etcd. And then there's already a broker that's been, let's say, if it's deployed, it's out there. Maybe that's called broker 0. Then, for example, the monitoring configuration gets introduced through the agent and everything, and then probably this is what it might look like at this point of time. I'm not sure. This is just my understanding of how it might work. So, for example, there's a MQTT client, which is, let's say, the Sparkplug B compliant client, which can actually read those protocol buffers, information that's being published on the broker itself. And then probably there's a gRPC server, which I actually found out it's part of also the OPC UA implementation. And then, for example, the applications might then just contact the server itself and then probably get more information out of it. This is how I currently see it. I'm really not sure, but that's why I've maybe kept, we can discuss this later on and then maybe come up with some common grounds as to what makes sense. And then the last part is just the discussion point. So the interesting thing about the specification itself is they have two levels of separation in terms of hardware. So chances are, if you have very strict microcontrollers which don't support a lot of operating system stuff. You can still, for example, program these kind of microcontrollers and then publish this information on an MQTT broker, which probably might either run on a server or a Raspberry Pi or a single board computer. And they call, for example, these kind of things edge of network devices. So EON, if one goes through the specification, that's quite a common terminology they've been using. And then device can be, for example, the sensor or an actuator that's actually mounted on these kind of devices. So that means it can be a digital temperature sensor, maybe just a switch, an LED or something like that. That's what the specification defines as a device. What's interesting is this EON and devices are exactly what, for example, you see in terms of the topic description. As you can see, it's an edge node device. So something goes over here. Maybe that could be a Raspberry Pi, maybe like a Atmel microcontroller. And then the device over here could be your, for example, the specific temperature sensor, maybe a switch, an LED. It's up to you, but it's so it's good to know that there are these two terminologies which might be good to keep in mind when for example, bringing MQTT plus Sparkplug to Akri. And then that's the question, but I've jotted down certain questions because I'm still not sure about how this fits into Akri, is where, for example, if you have a case where you have a Raspberry Pi and it's maybe it has this capability of running an MQTT broker on it. So should the monitoring broker pod actually run on it, exactly where it should run in this whole landscape? Or is it something that that one visualizes where, let's say, a broker is actually on premises on a server somewhere, and then, for example, the monitoring pod is like a small single board computer within this particular network? If you can clear this off later. And then how does this discovery handler for Akri actually look like in this scenario? Is it actually necessary to have a gRPC server in this scenario itself? Because let's say it's a publish subscribe mechanism, so chances are if there's something new, then there's a specific topic for that stuff. And then do you actually require a discovery handler for these kind of things? And yeah, correct. So these are the open points. And eventually I found out that they have a new version out, which is version 5, which is much more matured. However, there's lots more complex stuff inside it. So even though MQTT itself is a publish subscribe mechanism thing, apparently the version 5 now introduces a lot of newer concepts such as request and response. Even though your system is publish subscribe, you can still do the standard request response kind of things. It's quite new. I'll have to go deep diving in the new specs, but might be interesting. Maybe it turns out that it is a Deus ex machina, so to say, for Akri, where it actually ends up being quite nifty in terms of integration. So at this point of time, I'll probably just keep this discussion open at either in this call, or I'm also available on Slack for further discussions. And if you guys think I should document it in certain aspects, please let me know.
This is an awesome overview of all of your thought process with all of this. And I definitely want to look at your diagram on the previous slide in a second. Yeah. I will say that we have, there is one issue. I don't know if you already saw this, Shan, that a couple other community members have been discussing MQTT in that. I think putting your thoughts in there would be really helpful as well. Maybe you already have. And so I think we can continue the conversation there too. But I think my initial question, which is something you brought up in your last slide, is what does a discovery handler mean in this scenario?
Right.
So is the discovery handler a client of the MQTT broker, and then is basically saying, hey, these devices exist. So right. Now it automates that as devices subscribe to the broker and then go away, Akri's automating the bring up and bring down of the associated clients. Is that the benefit there?
So just this is how it is. So from my work experience, I do a lot of research over here. It turns out that like the point that actually is like the selling point for Akri is like you're bringing the concept of Kubernetes and resource management where there cannot be a Kubernetes. So for example, let's think about it in this aspect where you have a, let's say, a Bluetooth tag, something that just tracks some certain things inside within a certain geographical region. If you have, let's say, a Raspberry Pi that is still capable enough to run Akri and is somehow connected to this Bluetooth device, right? So that means if this device goes to another room where there's still a Raspberry Pi who does a similar action and then is still connected with the same, let's say, network logic, it might be interesting to actually use Akri's concept of discovery in terms of, okay, this device was previously known to me by this Pi and now is available for is now somehow moved to the next position or the next edge device within this, let's say, vicinity or something. This is how I understand Akri at this point of time. I might be completely wrong, but this is what I think might be quite interesting in terms of like, if this is what discovery handler is, then probably, yeah, then I think this might be an interesting way of looking into things where a lot of things can just be, for example, published. When something new comes in, then there's a specific topic for it that's already in MQTT. And then that can be used by, let's say, leveraged by Akri, and then says, okay, something is within this proximity and something has moved from point A to point B or whatever. So I'm not sure if I'm on the same page as you guys are, but this is what my understanding of Akri initially was, and it still is.
Thanks, Sharon. I do have another couple of questions. So yeah, thanks for the deep dive. It's my first time to deep dive into MQTT, so that was very good overview. Thanks for that. So you mentioned there's a broker and there's also a monitoring pod. So what is the monitoring pod for? Like, so the broker is so that others can subscribe, can actually subscribe to that and publish to that. But can you explain what the monitoring pod would be for?
I think that I took the concept of the monitoring pod from the OPC UA documentation that already has. I think the conflicting part is the broker. I think in OPC UA it's also called a monitoring broker, so to say. I think this is what one of the examples for the OPC UA is, where instead of, let's say, an MQTT client, they have an OPC UA client, which then, for example, talks to the OPC UA server. So I think it's like this entry point into the actual physical world of the protocol. So that's the part which actually talks the protocol, and then everything beyond that is what is necessary. For example, I think the gRPC server is something that is necessary for the Akri part of the whole scenario. That's what my understanding is. So I just sat down, went through the documentation, maybe just mapped it, let's say, one-to-one at this point of time, in order to just help you guys realize that this is what I'm thinking at this point of time. Chances are it might be wrong, and we can keep the floor open for more discussion and changes in this part.
Yeah, thanks for that. So one more question. You mentioned that there are many MQTT brokers out there, and based on what you said, most of them are kind of opinionated, I guess. So how does that work? Like, since you've been working on this for quite a while, do people usually just write their own MQTT broker that's very specific to their problem, or kind of keep it generic, but the schema of the topic itself is what is really specific?
Correct. The latter part is usually the case. Nobody tends to write a completely brand new broker, because the like I said, the specification, the protocol specification is quite hefty in that aspect. So chances are there are some great open source brokers out there. Everyone actually aims to be very compliant with the whole specification. So the brokers are out there. It's just for the taking at this point of time. What you generally then tend to do is either come up with your own, let's say, if you are an industry, you write your own topic, you design your own topics, and then you design your own payloads. Why? Because there are diversified systems in your company, which, for example, can talk in very different ways. So you are then free to choose whatever this can be. So for example, in my first part, I could be whatever, Acme, and then if instead of factory, I could be, let's say, shipyard or something like that, and I could be based where this is just an example. This is not complying to any form of specification. This was for me a completely, so to say, free balling concept, where I just thought maybe this makes much more sense, because the topic usually is the string that you guys see over here is also sent in the network packet. So that means it's quite interesting, because this can be all your metadata from which describes where this sensor actually is. So you can have 10,000 temperature sensors, but how do you know which one is, let's say, is prone to failure, or which one is actually giving you an actual information or something? So you can add the payload to you can add, let's say, the payload, and then you can, for example, use the topic in such a way that actually describes a lot of things here and there. So this is completely like a flexible.
Yeah, so again, one more question. So based on what you've seen, since again you've been working on this for a while, what is like the most common type of sensors or devices? Because again, if we went for the proposal of, hey, let's pick one hard coded for now, like not try to generalize it, like temperature sensors maybe, or
so I think like if you go off the shelf, just a very quick introduction to, let's say, how would I call it, like IoT 101 is just buying a simple environmental sensor, which is ones from hardware companies like Adafruit or SparkFun or whatever. So those are the sensors which cumulatively give you temperature, humidity, air pressure, all in one, and then you can integrate them with whatever that's with you on the table. For example, a Raspberry Pi or a microcontroller, and then you can, for example, get MQTT client libraries out there. They're all open source, and then you can program your sensors accordingly to send whatever information you want. However, so like I said, I think temperature and humidity are by far the easiest and the most prevalent examples of prototyping with MQTT and IoT.
Okay, so it looks like this will, based on what you said, is going to be very like the most useful for somebody to say, hey, I'm interested in this specific topic, and then regardless of where the sensor is, Akri can then it can request that through Akri as a resource, and then Akri takes care of communicating with the broker and kind of know where if the sensor is up and those kind of stuff.
Maybe, yeah, that's how I visualize it, at least at this point of time. So yeah, I'm pretty sure. I think it might it might fall into place eventually once we start like coming up with something concrete. Let's say maybe I think your suggestion about let's say coming up with a very dummy example or prototype might start to reduce the fog in this aspect, because the chances are there might be much more complexity which I'm not currently able to see at this point of time, but chances are it's better to start with a prototype and then report it to you guys for a better understanding.
Sounds great. Any more questions here, Kate, Brian?
Yeah, I have a couple more, but I didn't know if Brian wanted to jump in with any. No, okay. I was just wondering, so with the MQTT broker, I'm going to say MQTT before it because confusingly, Akri's automatically deployed workloads are also called brokers.
Yeah.
But I'm assuming there's one broker for a set of nodes, right? It's maybe running on one of the nodes, not on all of them, right?
Yeah. So I mean, it depends, right? Like it's if you have a very geographically diverse edge network, then chances are one Raspberry Pi is unable to cover a range of about, let's say, 1 kilometer or something. So then you might have to end up deploying much more than you think about. But however, a single broker instance in this case, so the software itself is capable enough to handle a lot of clients. And when I say a lot, I think they've done a lot of stress testing, and some of them claim to have at least 100,000 clients up and running to one certain broker.
That makes sense. So then the workload that is automatically, so Akri discovers a thermometer sensor by pinging the MQTT broker, and then automatically deploys a monitoring broker, or that workload specified in a configuration. That monitoring broker is connecting to the MQTT broker as a client, right?
Right.
So why does it, so what you were giving the example of a Bluetooth sensor that moves from being in the proximity of one node to the other,
Right.
why would that matter if no matter what they're reaching out to get data from a place, the same place? So whether or not the sensor is in one place or another, it's always publishing its information to that one broker. So why is there a specific node that is closest to it or not?
Well, I think in general, so this is what my understanding of, for example, in the edge paradigm is like, for example, the concept of high availability generally makes sense if you have, let's say, a Wi-Fi router which is very strong enough, and then you just have this one static IP which your sensors know that this is where I need to publish information. But then, for example, chances are if you have this kind of, let's say, dynamic sensor nodes out there, chances are if you move out of the range from one, let's say, one router, chances are that the other router that you enter in, for example, doesn't know or is not in the same IP environment, private network environment as the previous one. So chances are it might be quite interesting in terms of to see that, okay, this kind of sensor node is a dynamic one. It moves from one place to the other, yet it has not lost the information that previously sent to the last router or something like that. This is just my current understanding. I still have to be much more clear about what I'm trying to portray over here, but I think we can maybe I'll deep dive more into this, and maybe I'll answer your questions a bit more carefully next time. Like I said, at this point of time, I'm very sure about how MQTT works, how I can create use applications with it. But when it comes to bringing the cloud native stuff for example, the things that Akri is providing, I'm currently at this point not sure how I can bridge that gap between MQTT and what Akri is providing me at this point of time.
That makes sense. Thanks.
Yeah.
One more question. So what kind of applications are there? Is it more of data processing, since this is like probably also streams of data?
Right.
So
yeah, I think so since I've used MQTT quite a lot. So I've used, in one of my projects, I had to deploy, so to say, a sensor gateway box in a boat, and that boat is connected to, and that box is connected to, for example, the boat's backbone network, which is like a CAN network, where you can get all the usage information out of the boat when it's, let's say, at sea. And then you have to then, for example, send this information back to a central IT infrastructure, and this data then gets utilized by, let's say, a data analyst or, let's say, a simulation engineer, and then they can come up with some designs for their upcoming models. For example, you can have an accelerometer in your boat, and you can then see if the boat moves at, let's say, 15 knots, and how much of an impact does your boat experience in terms of G forces. You can't do this with a basic cable or a Wi-Fi or something. So then you have to create a hardware spec where you have to talk to, for example, your MQTT broker, which is on land, and then you publish this kind of information continuously from the boat, and then this data then gets stored in a, let's say, a time series database. You can see graphs, you can also plot the GPS maps, and then you can come up with an idea saying, okay, this is what the boat had to travel to in terms of the route, and this is how much the G-force impact it had. You can also use it in like industries also. For example, if you have let's say, if I've used MQTT quite often when when we have product scanning systems. So you can have a box which can have an RFID or a QR code, and it's very, let's say, environmental sensitive. So if it needs to be in a certain degree, certain temperature range. So you then need to, for example, introduce new sensors in the system already, and then then the protocol that you actually have to use is either something like a PubSub or maybe CoAP or something like that. But MQTT is quite prevalent. It's quite easy to integrate, so you can use that in those kind of aspects too. In fact, a lot of big big and small companies also provide certain MQTT clients and ports for PLCs, maybe also for a lot of other things in industrial spaces.
Thanks, Jan, for the detailed response. Any more questions, anyone?
Only question B, would you be willing to share these slides in the Slack?
Of course,
Awesome.
yeah, I'll do that. Yeah, all right. And one more question is regarding the issue that you mentioned, Kate, was the one by which was like opened back in 2019, 2020 or something, the one which has the MQTT discussion in it, right? From DDA. Okay. I'll have a look at
that's the discussion. But if you're interested in starting to work on a discovery handler, I could see making a new feature that is more of the design layout of it, but somehow finding a way to link them together. I don't know, Brian, any thoughts on like the best way to go about if we should keep using this issue or?
The issue makes a lot of sense to continue using until we can kind of hone in on what this is going to look like. Because even you're sort of learning here today, in my head, I wonder if we don't target the MQTT application to map that to our broker concept, in which case our discovery handler is really just trying to find MQTT brokers so that the application can be deployed to a place where it can see a broker. Thinking in my head that maybe like if I'm designing this system, you know, the devices have to know where their broker is that they're talking to. So that's not a real dynamic relationship. So what's the dynamic relationship is, well, where do I put my application? How do I get a highly available application and where do I put that? And so maybe that's where the mapping hits. It's that we make a configuration that finds a broker and a broker that has particular topics, and then the app is the container that they specify in the configuration that gets deployed as what we consider a broker, so that their application or our broker is always deployed in a place where it sees the data it wants to see. Versus kind of initially my thought was, well, maybe we can become kind of a demuxer of MQTT, right? So we deploy our broker, we deploy our broker, it finds an MQTT broker that has 15 different topics. Well, we advertise each topic and say, now these topics are available via our Akri broker / service, and then an application can use that. So I'm just not even sure how we're going to like create what we're going to create. And I think that the issue is a perfect place to sort of pin that down. And then once we have sort of clarity there, then we can move towards a proposal, and then we can move towards actual, you know, code. That'd be my thought.
Yeah, that's actually a great. I'll use that same issue, for example, to let's say come up with something on the table. I usually have a lot of sensors and things around, so I'll come up with some basic form of the situation that you see over here. So maybe let's say a client that does something, doesn't matter at this point of time, there's some broker out there, and I'll probably write a description of what actually is currently being done, and then from this point on, maybe that could be the discussion further on, and then maybe we'll take it from there on.
Right, and it'd be interesting to know, like, based on kind of, you come up with a topology and an application, and it's like, well, what are the challenges in setting this up? And of those challenges, are any of these things something that Akri could make easier? And then we could tackle kind of from that perspective and say, oh, well, yeah, you know, in this sense, I can't actually find it. I don't know where the topic is coming from. So maybe I can help there, or I don't know where to put my, you know, whatever it is.
Yeah, I think the one point that you mentioned, Brian, was the fact that, for example, let's say not everybody wishes to know everything, right? So there are, if you have, for example, in the context of this OPC UA, there's an example of an anomaly detection, right? So, but in the example itself, there's just one system that's providing you the information for your anomaly detection. Chances are in a very widespread industrial floor, or maybe let's say a home application, you don't want each and everything from everyone. Then maybe the idea of, let's say, just providing a certain amount of topics and then subscribing to only particular, let's say I'm only interested in the robotic arm and I don't care about the temperature sensor. Maybe that might be an interesting thing for the discovery part. And then the discovery handler, for example, says these are the topics that I've currently been actively aware of. And then from this on, I think that, and then the end user application then can just eventually feed in the topic, and then things can go on from there on.
Sounds great. I think we have good next steps here. We're looking forward to the update to the issue chain, and everyone can chime in with more comments.
Yeah.
That said, we're a little bit over time. So quick, we need volunteers for next Akri meeting, issue tracker, moderator, and notes taker. Anyone, everyone? Okay.
I can do moderator.
Okay, Kate, you're on it.
I can do note taking.
Okay. And I can volunteer for issue tracking then. So our next meeting is going to be July 6th. Okay, sounds great. Thanks everyone for making it and for the productive discussion. Have a great rest of your day, everyone. Bye-bye.
Bye, everyone.
Bye.